In this video, I'm going to talk about how we can integrate inverse trigo functions. Okay, so let's start off with the integral of sine inverse x. Okay, to do this, we have to use integration by parts, right? So if you recall earlier, I did a video on integration by parts. Okay, so this is how it works, right? In case you have forgotten. So integrate u dv equals to uv minus integrate v du. Okay, so this is the formula for integration by parts, right? So you can see from the formula that I need to identify which one is dv and which one is u. Okay, so in the case of this example, right, there's only a sine inverse x, right? So where's that second function? So I'm going to introduce a 1 here. So 1 is actually the second function. Okay, so dv is normally assigned to the function that is easier to integrate, right? So if you compare 1 and sine inverse x, so it's quite obvious that 1 is easier to integrate. Okay, so I will let this be dv. Okay, and then I will let sine inverse x be u. Okay, so this will be uv, right? V is basically x, okay, and u is sine inverse x minus integrate v du, right? So du differentiate sine inverse is 1 over square root 1 minus x squared. Okay. Okay, square root 1 minus x squared here. Okay, so the integral of x over square root of 1 minus x squared. So actually, I mean, just a quick intuition, I roughly can tell that, you know, if I differentiate 1 minus x squared to the power of half dx, okay, I'm going to get half 1 minus x squared to the power of negative half times negative 2x, right? So that gives me negative x over square root of 1 minus x squared. Okay, so that's great, right? So basically, you can see that there's a strong resemblance here. Okay, so I can say that, right, negative of this is basically x over square root of 1 minus x squared. So if I were to integrate everything with respect to x, okay, so this would be equals to, okay, so let me write it nicely. Integrate x over square root 1 minus x squared is equals to the negative of 1 minus x squared square root, right? Okay, so the integral and the derivative here will neutralize each other. Okay, so let's go back here. Right, so this is equals to x times sine inverse x, and this will be negative square root of 1 minus x squared, right, plus c. Okay, so simplifying that further, you should get x times sine inverse x plus square root of 1 minus x squared plus c, right? And that is our integral of sine inverse x. Okay, so let's try that for cosine inverse x. Okay, so it's basically the same strategy. Okay, so integrate cosine inverse x, right? So again, I'm going to introduce a 1 here. Okay, so I will let this be dv, okay? And this be u, okay? Okay, so not to forget the dx here. Okay, so this is uv, right? U times v. That will be x times cosine inverse x, right? Minus integrate v du. Okay, so v is x, and differentiate of cosine inverse x is, okay, let me just write it this way. All right, so what is differentiate of cosine inverse x, right? It's negative 1 over square root of 1 minus x squared, right? Okay, so let's simplify that. This would be positive square root of x over square root of 1 minus x squared dx. Okay, so if you recall earlier, let's go back to what is earlier. Right, when you integrate this, you get this, right? You get negative of square root 1 minus x squared. Okay. So this is negative of square root 1 minus x squared. Okay, so let's rewrite this nicely. So this is x cosine inverse x minus square root of 1 minus x squared plus c. Okay, so that will be our integral for cosine inverse x. All right, so let's try it on tangent inverse x now, right? So maybe spend about a minute and try it for yourself. Okay, so let's go to tangent inverse x now. Okay, so same thing, I'm going to introduce a 1. Okay, so identify which one is dv, right? So 1 is obviously going to be dv here. And tangent inverse x is u. Okay, so this is uv, right? So uv is x times tangent inverse x minus integrate v du. So x, differentiate tangent inverse x is 1 over 1 plus x squared. Okay. So this is x tangent inverse x minus integrate x over 1 plus x squared. Okay, so if you notice, the numerator is very close to the derivative of the denominator, right? In fact, if you differentiate the denominator, you will get 2x, but this is an x. I'm going to introduce a 2 here, and then introduce a half outside to neutralize that. Okay, so why am I doing that, right? Because I want the derivative of the denominator to be the numerator, right? And then that will just be a logarithm. Okay, so this is negative half ln of 1 plus x squared plus c, right? And that is the integral of tangent inverse x. Okay, so I hope this video helps you, right? If it does, please remember to subscribe and like the video. And I'll see you again next time.